Dear students, let us uh, start now discussing about Zeta sizer for evaluation of nanoparticles. Okay, and okay, let us start. Zeta sizer measurements of nanoparticles, size distribution, dispersion properties, stability, and propensity to aggregate are crucial to the design of both nanoparticles as well as nanomaterials or new nanomaterials. Okay, so Zeta sizer is used for measuring size distribution, dispersion properties, stability, and propensity to aggregate of nanoparticles in a nanoparticular dispersion or particles of nanomaterials. Okay, this helps in the design and development of new nanoparticles or new nanomaterials. Okay, so zeta sizer is, by which we can say that zeta sizer is used in the design and development of new nanoparticles or new nanomaterials for various applications. For example, like for drug delivery. Okay, so here the very large surface area of the nanoparticles or nanomaterials may result in novel physical and chemical properties such as increased catalytic activity, improved solubility, or unexpected optical or toxicological behavior. Okay, so the principles and methods behind the zeta sizer measurements or measurements using zeta sizer are as follows. The main principle of any kind of measurement using a zeta sizer is the light scattering. The light scattering of the light scattering by the nanoparticles from its dispersion, from its dispersion. Okay, so let us start. Light scattering is a fundamental analytical technique for the characterization of particulate materials and is most commonly applied to colloidal systems, nanoparticles, and macromolecules in solution or dispersion to determine particle size, molecular size, or electrophoretic mobility. Okay. Different methods of light scattering analysis provide a range of useful information about the samples, the nanoparticular samples. Okay, and these methods of scattering are dynamic light scattering, electrophoretic light scattering, etc. We have um, one more type of light scattering that is not commonly used, but these two types of light scattering called dynamic light scattering, the abbreviation is DLS, and electrophoretic light scattering, the abbreviation is ELS, are commonly used for various measurements of nanoparticles or nanoparticular dispersions using zeta sizer. Okay, uh, during the searching of during the searching about zeta sizer in internet, I found various models of zeta sizers. Okay, and I found Zeta Sizer Nano, which is I found a model Zeta Sizer Nano, which is from uh, a series of malware Zeta Sizers from a company. Okay, most useful or most appropriate for various measurements with regard to nanoparticles or nanomaterials. Okay, and apart from Zeta Sizer Nano, the other models are also available, like Zeta Sizer Pro, Zeta Sizer Ultra, etc. Okay, all these types of Zeta Sizers are advanced versions. Okay, so let us discuss about the principles. Okay, so instead of during my discussion, instead of speaking dynamic light scattering, I will just speak DLS, and instead of speaking electrophoretic light scattering, I will speak it as ELS. Okay, so DLS measures the size distribution of molecules and particles, whereas ELS measures the electrophoretic mobility of particles or molecules in the dispersion or solution. Okay. This is often converted to a zeta potential. Okay. Think about the will take a dispersion of nanoparticles. For example, using DLS, we can measure the size distribution of nanoparticles in the dispersion. Okay, and if we take a solution, we can measure the size of the molecules present in that solution using DLS. Okay, coming to ELS, we can measure the electrophoretic mobility of particles or molecules in dispersion or solution respectively. Okay, and this electrophoretic mobility later will be converted into zeta potential. So like this we'll get the data of size and size distribution of particles, size of molecules, electrophoretic mobility values, zeta potential values from by using of these two principles. Okay, and this data is often critical for establishing as well as optimizing the sample integrity and stability, including the detection of aggregates or agglomerates. There may be aggregates or agglomerates, nothing but same. Okay, they may present in the dispersion. They may present in the dispersion or solution. Okay, and routine use of this light scattering analysis helps in fast formulation development, gives greater insight into the stability assessments, and helps to elucidate and solve product as well as process challenges. I repeat once again, routine use of the light scattering analysis helps fast formulation development, nothing but increases the speed of the formulation development process, gives better insight into the stability assessments of the formulations developed, and helps to elucidate and solve product as well as process challenges in the process of formulation development. Okay, so Zeta Sizer has been imperative in allowing the scientists to analyze drug-loaded polymeric nanoparticle formulation batches with consistent results. Okay, and the instrument is easy to use and allows for numerous analytical combinations. Okay, so we have discussed about light scattering and the utility of light scattering. We have discussed about light scattering, its types, and its utility. Okay, and let us now discuss. Okay, why we have to use light scattering only? Why we have to use light scattering principle only for various measurements using zeta size? So there are various types of light scattering. We know already about that, and each of these are designed to provide useful and actionable physicochemical information on the sample being analyzed. This also we know. Okay, and the zeta sizer offers two types of light scattering technology as a standard, DLS and ELS. This also we know. Okay, and the frequency and intensity of the scattered light can be measured to determine the size and charge of the materials. Okay, so this also we know. This information is commonly used to shorten development time for and to improve the stability of colloidal as well as emulsion formulations, and to assess the level of aggregation in the system, in the dispersion system or colloidal systems. Okay, so all this we have already discussed in our first paragraph itself. Okay, now let us continue, and now let us continue our discussion of let us continue our discussion about the dynamic light scattering and electrophoretic light scattering in our in our next video. Okay, so I'm making the videos of around 15 to 17 minutes only. Why? Because there is a problem in my phone. Okay, if I make a video of 30 minutes continuously, and that the video file that is occupying more than 3 GB, and it is becoming for me difficult, it is becoming difficult for me to compress that video into few MBs and upload it into the YouTube. That's why I'm making the videos of about 15 to 17 minutes and compressing them and finally uploading them into the YouTube. Okay, and sorry for any difficulty. Okay, so I will start will continue our discussion in our next video. Thank you.